So, hello and welcome back to my exploit development playlist. In this video we will take a look at the second challenge from ROP Emporium called Split. And in this challenge we need to prepare a call to system manually and load a string into a register as an argument for system. And yeah, let's see how that goes. First of all, to download the binary again. And then we can open it up in GDB. So what we need is, of course, the offset again. So let's keep track of this here and create our solve script. Of course, we want everything from pawn again. So what we need is the offset where we over pointer on the stack again. Then we maybe need a return gadget or stack alignment, possibly. Then we need the actual string in cat, which is basically the string here that cat's flag. And then we will need a gadget that will load that string from, that will pop the string from the stack into the RDI register because of the x64 calling convention. So we need a gadget. Then of course we need to have the address for system so we can call it manually. So that also needs to be in the stack. And then we can prepare our exploit payload. And for the padding, we will again use a times the offset. Then possibly we need the return for stack alignment. Then the pop RDI that pops the next thing from the stack into RDI. So the next thing we should put here is the cat string, the cat flag string. And then lastly, after our register is prepared, we can call system like so. And then we can open the process, then send our payload, and then we can switch over to interactive mode. So let's get started. First of all, let's get the easy things. So system can be found here. But it seems to be a really high address. So let's see if we can find another address. First of all, we need the return gadget, and we can just use the return from main here. So copy this, paste it in here. Then we need the cat string. And we have found that here. Then we need to find the actual offset. So turn create 100 and continue. Let's put this into here. Pattern at RSI. Sorry, RSP. And that seems to be at the offset 40. So let's note that down. Then let's see. Okay, let's quit out of GDB and go and use ROP gadget. And let's search for pop RDI. Oh, sorry. Of course, we need to pipe it into grep. And looks like we have a good gadget here. So let's use this one. And then lastly, we only need to have system. Let's see. Maybe we have something here. So looks like we have our system address here. I'll peek there for a second to take a look where we are in the binary. And here we just jump to the ELD, which should be fine for us. So let's try that. And let's input that. 460. Let's see. Fingers crossed. We can also receive here again. Or we can use send after. And then we had this little thingy here. And also we don't need any interactions, so just receive all and print that out as a success status. And let's see if that works at all. And looks like success. We got our flag, so that was lucky. And I want to make this a little bit more reliable, so let's improve the spawn script here a little bit. So first of all, I want to save our binary into a variable and actually tell pawn tools that this is an ELF file and it should load it as an ELF file. Then we can set up the context binary as our ELF, so pawn tools knows that we are using this as our binary and can also fetch information from it. Then we don't want to display all the information about our binary anymore, to make it cleaner looking. Then we don't need to specify the binary here anymore because it can be inferred through our context. Then we can create a helper object for ROP, so we can use that to search for things in our binary. For example, the return gadget. We can simply then use our ROP object. And here we have already the find gadget method. And here we need to specify the instructions that we want to find, and this returns a list, so we need to index into it. And let's see, not sure why this pops up. This should be the correct syntax. Let's just try if that works or not. We can do the same thing for our pop RDI. And also here we want to use the first thing that we find. For cat we can use elf.search, and we can here search for bytes. Here we can search for this string, and this returns a generator, so we need to call next on it to also get the first result of that. But here in our system, for our system, we can just read it from the symbol table. Like so. Not sure if we need this to be a byte string. Probably not. I'm a little bit confused why this here pops up. This shouldn't return none. So let's see if that works at all. Okay. So that didn't work correctly. Maybe we need to have it as string. RDI, of course. RDI. And then the next instruction should be a return, like so. We have the offset, we have the return. Maybe we don't need that. We have the pop RDI. We have the string. Okay, let's try this again. Try putting this one in again. I think we need it because it worked first. So try it again. And as we can see, we've solved it. But why do we have the bytes warning here? Let's see why that is. I would like to have that not in there. Yeah, I'm not sure why that causes it. What causes that? But as we can see, we've solved the flag, the challenge again, with this time with dynamically resolving all of the addresses. We don't have any hard-coded addresses anymore, and that's really pretty, I think. So with that, I would leave you for the next video.